Hello everyone, it's Benny, and welcome back to the 3D game programming tutorial series. Last time, we finished the ECS system by and large, minus a few minor things we might add in later, but it's pretty much done and solid. Which means, now we have the critical elements in place to start actually doing some game development. And that will be what this video is about. We're going to start planning out our game, we're going to start building it in the ECS and see how things start looking, right? Well, not exactly. That is still going to happen, that video is still coming, but it has been slightly deferred to the next video. And the reason is, as I started doing that part, I realized all the coming back to do the minor aesthetic changes to ECS, it just got in the way and distracted, so it's much cleaner and nicer just to finish off all the minor ECS things now, keep the ECS in its one big solid unit, and then the rest of the time we don't have to worry about it. We can just use it as if it's from some external library and just build our game, because that's really what we want to do. We just want to focus on building the game. So my apologies for being slightly misleading last time. I don't like doing that, but I can guarantee you 100% in the next video we will be starting game development, because I will be doing it immediately after I finish recording this video. So there you go. And yeah, with that, let's go ahead, let's dive into it. Alright, and next up, we are going to be fixing a very sneaky issue in ECS Component HPP. Why is it sneaky? Because it has to do with static variable initialization order. Now, my understanding of static variable initialization order in C++ is for every individual compilation unit, that is, every individual CPP file, static variables should be initialized in the order they're declared in. I'm pretty darn certain that's in the standard somewhere. So, logically, if I'm declaring some CPP file that does something with ECS components, it should have to include this file first, and therefore this static component types variable should be declared before, well, any of those components are used. That seems like the logical thing. It seems like this static variable should already be there and declared in every case, because you need this file to declare components. Unfortunately, that's wrong. Why is it wrong? I really don't know. It seems, I don't know why it's possible to violate that, but apparently it is. So what we're going to do is we're going to modify component type so it does not depend on static variable initialization order. Just so that we don't have to deal with that issue. I don't know why exactly it's possible to do that again. If someone who's an expert in the C++ standard can tell me about why it's possible to somehow declare static variables that would use component types before it's constructed, that'd be nice. I don't know why, but somehow that's possible, so here's how we're going to fix it. What we're going to do is we're going to change component types to a pointer. Why a pointer? Because there's another subsection of the C++ standard that says if a static variable is used before it is initialized, it will be a null pointer, or rather just all zeros, which is a null pointer. So we can take advantage of that. What we can do is under, whoops, wrong file, the CPP file, we're also going to change our declaration to a pointer, and we're also going to provide no initialization. We're going to take advantage of that default 0 initialization to do this. What we're going to do is in here, we're going to say if component types is a null pointer. Because if it is, then we're going to do lazy initialization. Then we're going to say component types is a new giant array of nonsense. And then we should be good to go. This does mean we need to change the syntax a bit. Right here, we need component types size. There needs to be arrow notation because it's now a pointer. Here, again, arrow notation because now it's a pointer. I believe that's all the usages here. Let's see. Here, again, component type size, arrow notation because it's a pointer. Here, I'm going to do it like this so that I can access this operator. I think there's a way to do that in pointer notation as well, but, well, this works. So yeah, we're dereferencing it to get the base type and then finding the correct index. And I believe that should be everything. Let's actually do a quick build to see if I am right about this. So let's just make. And awesome, that is indeed everything. Let's go ahead and just run real quick. Sweet. So that should fix this static initialization order issue for anyone who's had it. So, one very small bug fix in ECS.cpp under remove entity. So ECS.cpp remove entity, we are moving the entity to the destination index, we're swapping the entity, but we don't change the index. If you remember, if I look at our entity to destination index, it's a pair. The first part of that pair is its index in this entities array. So we need to update that. We've moved it from the source index to the destination index, so we're going to set this index to the destination index. So therefore, that, well, index reflects, hey, this is the index that we are at. And there you go. That is all. One very small line, but if you didn't have this, you'd get a whole bunch of different errors and everything would work correctly. So, yeah. So, to begin our changes to the ECS, let's go to the system for probably the biggest change. How does our system work right now? Right now, we have this list of component types, and what our ECS will do is it will go through our entities, one way or another, and it'll say, hey, if this entity has one component of every component type the system needs, then it will call update components with all those needed components. So we can update the entity specifically at the components the system is interested in, which is good. That's mostly what we want. But what if we have one component where we might want to process it if it's there, but if it's not, it's okay, we still want to process it. What if we want to have an optional component? Like, the entity doesn't have to have this component, but if it does, please tell me about it. You know, something like that. That is what we're going to implement next. So the way we're going to do this is we're going to use flags. So what I'm going to do is just create an enum for our flags. I'm going to say flag optional, spelled correctly. There we go. That's just going to equal 1. Right now, that's the only flag we're going to have. What we're really doing here is sort of future-proofing. We're going to need all this code anyways. This is going to make it a little bit more general in case we want, say, some slightly more advanced features later. So, yeah. So, we're just going to have an extra array for flags. That's all we're going to do. We're going to create another getter, just like this, except it's going to be get component flags. And it's going to return component flags. There you go. That's really almost all we need here. The other thing we're going to need is some way to actually, set the flags. Because right now, all we're taking in is an array of component types. Now, we could take in an extra array for the flags, but at this point, it's probably a little bit cleaner if we just do away with the direct constructor and provide a different way to do it. That should be a little bit cleaner. So this is our default constructor, does absolutely nothing. And what we're going to do instead is we're going to have a protected method. It's going to be void, and it's going to be something like add component type. Yeah, sure. It's going to take in the component type, of course, but it's also going to take in the component flag. So this is a nice way to just initialize the array without dealing with all the various pains that would be associated with this. Like making sure all the arrays are the same size, making sure they don't forget something. This just handles it all for it, so it's very easy to set up, very easy to change in the future. So component types, we're going to push back the component type. And component flags, guess what? We're going to push back the component flag. And that's about all we need. So that should pretty much wrap up the changes we need in here for the time being. Though actually I'm going to leave this up for a moment because what we're going to need to do next is go into ECS, and what we're going to do is we're going to go down, Well, really, I don't know if we need to change anything in the header right now. So we're going to go into the CPP file instead. Just go directly there. And we're going to make a couple changes. How do we implement optional components in our update system with multiple components? So, actually, this is going to be really, really easy to implement. The first thing, of course, we need the flag. So I'm just going to copy the data type. I'm going to have a const array uint32 reference called component flags, and that's going to be equal to systems subindex, and we're going to get, actually I think I have something like this before, yeah, systems, oh, well I don't, but that's fine. Get component flags, there you go. Now we have access to the flags. So what? How do we determine if a component is optional? Well, if you think about it, all the real logic should be here, because this is where we're setting up the components and ultimately deciding whether or not the system, or excuse me, this entity is a valid match for the system. So all we need to do really is if the component is null and it's optional, then say it's still valid because it's optional. That's all we need to do. If we do that, everything else should work out just fine. So I'm literally just going to do that. And component flags sub j, what we're going to want to do is we're going to want to mask out the base ECS system flag optional. If this flag is 0, so what this means is if the optional flag is 0, that means component is not optional. So only if it's not optional and it's null does this become invalid. If it's optional, then this is totally okay. We don't care. It's okay for this component to be null because it's optional. I mean, that's the definition of optional components. There's no more real logic needed. Except for one slightly tricky thing. Because of our find least component thing, what we want to do here is we don't just care about any least common component. We need the least common non-optional component. So, to fix this, we're going to need to change the definition of this in the header slightly. We're going to need to take in an array reference for, well, the least common component. So I'm going to change the header over here. We're going to go to where we have find least common component. And there you go. We're taking in component flags. That's pretty much all we need in order to do this determination, as far as header file changes and such. So there you go. Now we're taking in component types and component flags. Go figure. But that does leave the question of how exactly we do the logic. How do we say this component isn't optional? Well, we're going to do the same sort of logical tests here. So in fact, I'm just going to copy and paste this. We're going to copy this if statement. And what we're going to say here is if component flags, in this case, the iterator index is I, so if component flags I is optional, so if the flag is not equal to 0, then we're going to just ignore this. We're not going to consider this for potentially being the smallest size. But this does introduce a subtle trick, because right now our current system of initializing to the first one is no longer valid, because this might be an optional component for all we know. So instead, I'm going to start at index 0, and what I'm going to do is I'm just going to initialize this to a uint32 -1. And this is because if we subtract 1 from an unsigned integer, by definition, unsigned integers can't be negative, so 0 minus 1 in an unsigned integer must wrap around to the largest possible value. So anything should be less than this other than the largest possible value. But what if it is the largest possible value, you might ask? Well, really that shouldn't happen too much, but just to be on the safe side, to make sure this is logically correct, we're going to change our test to less than or equal to minimum size. So it's not going to really change what we need it to do, but it'll avoid that edge case if for some reason it would ever come up. And there we go. This is all we're going to need to implement optional components. We can now have optional components. Or can we? Because wait a minute, viewers, it's not quite over just yet. There's one final edge condition that we need to account for. I know, this is really the only hard part about optional components. The logic, really simple, but it introduces a lot of edge cases and a lot of loose ends you just have to wrap up for everything to work right. It's a little annoying, but that's what it takes. And in this case, the final edge case is, well, what if we create a system that requires only optional components? That's not going to work. Our find least common component is going to return -1 size and -1 index, and the whole thing's just going to break down. And really, that's actually okay. It should break down because it doesn't make sense to have a system where every single component is optional. You need at least one component to identify what on earth you're working with, other than just go through every single entity in the scene and tell me which ones have these various components if they do at all. No. You need one non-optional component. So we're going to fix this with a Boolean is valid for the system. And actually, we're going to implement this in the CPP file, which we don't have yet. So ECS System.cpp is going to be created. We're going to include ECS System.hpp, and we're going to implement this Boolean is valid. How on earth do we implement this? Well, actually, like I said, the logic's not that difficult. All we're really testing here is how can we determine if the component, how can we determine if we have one component that is not optional? At least. It can be more than one, but at least one component must not be optional. So, very simple. We're going to iterate through the flags array. So, for Union32 I equals 0, I is less than component flags dot size, I plus plus, sure. And what we're going to do, very similar check to what we've been doing all along. In fact, I'm going to copy and paste from our ECS component, just straight up ECS.cpp file. We're going to say if the component flag, we're going to mask out the optional bit. If this bit is not equal, if this is equal to 0, so this component is not optional, then what we want to do is return true. Otherwise, if we went through everything, every single component is optional, we will return false. Dead simple. And we could do logic in here, but actually I'm going to do the logic in the header. What I'm going to do is I'm going to change add system to be Boolean. This can fail. And how this is going to fail is simple. If system.isValid, well, actually I can even do this even simpler. If it's not valid, return false. Otherwise, add to the system and return true, not false. There you go. And that does wrap up everything we need for optional components. That is it. We'll only add valid systems to our ECS. It will handle all the optional edge cases correctly. We're done. So, we completed the big addition by having optional components. Now we're going to add the other big addition. Not quite as big as optional components, but bigger than everything else in the video. So, what we're going to do is we're going to refactor the systems completely out of the ECS class. And there's a few reasons for this. Some of it is just general object-oriented design. It's better to keep things separated if you can. And the more concrete, specific reason is it gives us more control of our systems. If we want to have one list of systems for our game mechanics, one list of systems for physics, one list of systems for rendering, just for example, we could do that. And then we could update them individually only when those particular sets of systems need to be updated. So we don't have to update every single system of every single type in the entire game every single time we need to update anything at all. We have more control over what gets updated when. That's the big reason we're doing this. So yeah, we're going to move the systems out, and we're just going to take in systems as a variable to update systems. So how do we do this? Well, we're going to create a class in ECS system called ECS Systems List. There we go. We're going to have public members and private members, and we're literally just going to straight copy and paste base ECS systems into there. Same thing with add system, where we're going to straight up copy that, move it into here, and remove systems. We're going to directly copy that into the ECS systems list. And we're going to need to go to the ECS Systems.cpp, scroll down to our remove system method, and move that into this, and change it to ECS System List. And there you go. That's all the moving around. We do need 2 more additions though. The first is we want an inline void, size t, called size, which is just going to be a straight up wrapper for systems.size. And we're also going to have an inline operator. We're going to overload this, the parentheses operator. It's going to take in a uint32 index. Again, just straight up wrapper for systems index. Oh, and it's going to return, of course, a base ECS system pointer. There we go. That's all we need in our ECS system list class. So, next thing we need to do, change ECS to use this. Going to be very, very straightforward. Take in ECS system list, reference ECS system list, go figure. And we're going to need to change update systems to take this in. And yeah, pretty much everywhere we have systems, we're going to change to ECS system list. So, in fact, I'll just rename it to systems straight up, so I don't even need to do any renaming, and it's also really a perfectly fine name, so yeah. There we go, that's all we need for systems. The other thing, we need to add this to update systems with multiple components. So I'm going to pass in systems to here. I'm going to change the header to include the ECS system list as a parameter. And, oops, now I just need to change it down here as well. And we're just about golden, really. So I'm just going to double check to make sure there's nothing weird being done with systems that we can't handle. Nope. We are good. We have everything done with the ECS systems list. There we go. We are done. So, we can close ECS system.hpp because we are done. And in our header.hpp, there's a couple things. First of all, we're going to want to edit get component internal to actually have a return value. That's something I forgot to do in the last video. So there you go. And that's all we really want with components. Beyond that, components are fine. I am happy with them. Make entity, pretty happy with it. There's one minor thing we can do just to make it a little bit nicer, and that's taking components by a double pointer rather than a pointer. That way, it's easier to have various types of components and just put them in a list. Yeah, just make it various types of components, put them in an array of pointers, and just put all the pointers to the components you want. Much easier to set up than doing it with a single pointer. So you'll see that really very soon, sooner than you might think. But yeah, we're just going to make that change. It's going to be very simple, changing it to an extra pointer. So instead of taking the address of this, we can just refer to it directly. And yeah, that's it. That's all we need to do there. And now it's time for our final aesthetic change. Because wouldn't it be nice if I could say make entity and somehow it did all the setting up the components list and components IDs for me? Because there is a way to do that. Let's say, for sake of example, I have 3 different components. So I'm going to take a template, class A, class B, class C. We're going to assume these are some type of base ECS component. We're going to have a make entity handle for this, taking in, well, an A reference, a B reference, and a C reference. How can we automate the creation of components like this? We're just assuming A, B, and C are some different type of component. Well, what we do is we take an array of base ECS component pointers, and I'll just call it components. That's an array. It's going to equal to, oh, I forgot to name these. I'll just call it C1, C2, and C3. C short for component. C1, C2, and C3 will be in our array, specifically the address of them, because we want the pointer. So we take the address of C1 to get its pointer. We add those pointers to this array. We also want a uint32 pointer, array for component IDs. Also very straightforward. It's just going to be A ID, B ID, C ID, right? This is exactly what we do if we wanted to use the big, bad make entity method. So with that, we'll just return make entity, taking in components and component IDs, and 3 for the number of components. And there you go. This is how you can create a method to automatically create an entity just by passing in the 3 necessary components. It will automatically detect the type. It will automatically handle all the proper setup. Very convenient for creating it. I can literally pretend I'm in the main method. I can just say, hey, ECS.makeEntity for my transform component, my cool component, and a hot component. Sure. There you know. There you go. This is what we can do. It'll create the entity. We don't have to do anything fancy beyond this. So that's an awesome way to make entities with one small catch. Right now, there isn't much of a better way to do this beyond setting up a template like this for every different number of components. So if I wanted 4, I'd add class D, taking in a D reference C4, and again, address of C4. And this will also take in DID, and we'll change this to 4. Just do this all the way up to some reasonable maximum, like say 10 different types. And yeah, just create a whole bunch of overloads for every different possible number of components you want to add. There's not really a better way to do this right now. There will be a better way to do this later on in the series, but that's well down the road before we get there. So what I'm going to do is I'm going to set all these different types up off screen, just like this, from 1 all the way to 10, so you don't have to bear with watching it. And if you don't feel like typing out all that code, you can just copy it off of GitHub. And that is all we need to do to make our ECS system pretty much final. Doesn't need to be touched again. Okay, and everything looks good, except for one small warning that I missed. Right here, I want to put the parentheses around this, not the equal 0, because operators like this in C++ have weird order of precedence, so we have to put parentheses so this AND gets done before the comparison. For example, in ECS System.cpp, line 6. And we're going to go ahead and do that for all the rest of them. So everywhere else we did a comparison like this. So like line 140, what we're going to do, same sort of thing, change this, get rid of that parentheses. There we go. Just as long as the parentheses are around the component flags to the flag optional part, you're good. We also need it right here. Here we are. Parentheses here. There you go. And I believe that should be all the warnings. Let's go ahead and build and run to be 100% sure. And there we go. That appears, yeah, all the warnings completely done. So with that, that will conclude building the ECS, by and large, for a very long time. But what about actually making a game with this? Find out actually next time. I hope you enjoyed, I hope you learned, and I'll see you in the next video where we will definitely 100% be starting on building a game with the ECS system. Thank you, and I will see you in the next video. As always, if you're interested in talking more with me or other like-minded people, please join the Benny Discord. It is an awesome place. It's only been getting better recently with more and more people joining and having an awesome time. It's great. Please join. It's an awesome community. It's a great way to get in touch with me and other people following the videos. If you are interested in finding out right now, or possibly getting special roles on that Discord, or possibly getting a special thank you in these videos, or you're just a cool person and you want to support me, then consider becoming a patron on Patreon, because you can get all of those things, plus more, because I forgot to mention I also sometimes post some bonus materials on there for people to enjoy. So with that, thank you very much, and a very special thank you to everyone listed in the video description. It's hard to believe how much that list keeps growing. People are awesome. Thank you all so much for your support. It is incredible. And I will see you all in the next video.